Hello everyone, you all are welcome to my YouTube channel Devotion of Knowledge. So today, as usual, we are going to do something related to programming, but today we are going to understand a very important yet very interesting algorithm named Dijkstra's algorithm. Let's head straight to the blackboard. Now, what is this Dijkstra's algorithm? What is it for? And it is applied on which data structure? So Dijkstra's algorithm is mainly applied on graph data structure. Now, many of you might think that graph data structure is relatively a tough data structure, relatively and complex data structures. I won't deny you that it is a complex data structure, but the algorithm that today we are going to understand is not that complex. It is not that tough to understand. It is straightforward, it is easy to understand, yet easy to implement also. It won't include any of the recursive approach and all that. It is used to find the shortest path in the graph. Now, shortest path can be calculated using many tricks or using many algorithms. One of them is using troposort. One of the way which we are going to understand today is Dijkstra's algorithm. There are many ways, but the primary difference between these two algorithms is troposort uses DFS, Dijkstra's algorithm uses BFS. Now, DFS is a recursive approach where recursion is used to implement the algorithm, while BFS is iterative approach. Here we won't be including any kind of recursion and all that. It is completely based on iteration, means for loop, while loop and all that. We won't be including any kind of recursion. Let's move forward. Dijkstra's algorithm can be implemented in many ways. There are mainly three ways in which we can implement Dijkstra's algorithm. One is using normal queue data structure. One is priority queue data structure. And the third one that we are going to see now is a set data structure. We are going to code for the set data structure. I have previously written the code for priority queue, a way to implement it. I will be explaining that also. But we won't be doing for the queue data structure. Well, the implementation is almost similar to priority queues way, but we will be discussing some of the pros and cons for all the three approaches. And the best approach is either priority queue or set one or the set approach. Queue data structure we won't be using because it includes some of the function call, not functions call, but iterations which are unnecessary. We will be understanding it in the end part of the video, but till then, let's move forward. Here is the graph given to us. Now, as I told you, we'll be using a queue data structure, sorry, a set data structure, and as we are supposed to find the distance from source to all the nodes. So at the end of the problem, we have to return that particular array which denotes the sum of the source node to that particular node or all the nodes of the graph. So we will be maintaining an array. Here are 5 elements. So 1, 2, 3, 4. Yes, this one is, yeah, it is 6 elements. Sorry, because it is 0 to 5. Okay, 0, 1, 2, 3, 4, and 5. Yes. Now initially we will be assigning value of infinity to each and every path. Why? We will understand. And the distance from the node to the same node is always 0. Why? Because see, we are supposed to go from 0 to 0. How much distance will it take? Obviously 0. So the source that will be given in the question, we will assign let just name this array as dis array. So we will always write dis of source will be always 0 because the distance from going to the node to the same node is always 0. Okay, now let's move forward. So in the set we will initially insert the value 0 and the node, source node. See, in the set we will be maintaining the distance and the node. Please remember this. Now, why we are using the set data structure? Because set data structure stores only unique values. Okay. Values in the sorted form. Okay. And it is relatively easier. You will understand why. Okay. Now, okay. So initially we will be inserting 0, 0 in the set. Now, this is the adjacency list. Okay. From 0, we can reach 1 and 2. From 1, we can reach 0 and 2. From 2, we can reach 0, 1, 3, and 4. Okay. From 3, we can reach 2 and 5. From 4, we can go to 2 and 5. And from 5, we can go to 3, 2, and 4 as well. Okay. So this is our adjacency list that will be given along with the weight. Okay. Now, we'll be starting from the adjacent elements of the 0. Okay. Node is 0 and the distance to go up to that node is 0. Now 0 can go to 1 with the distance 2 as it is written here. Now we are having infinity into the array because initially we will be storing infinity. Then if we are getting some distance, then we will be comparing the distance to the already present distance in the array. So when we are getting an initial distance, it will be always less than infinity. So it is more better for us to store something which is maximum possible. So that's why we have written infinity. Okay, so distance from 0 to 1 is 2. Okay, so we'll erase infinity, we will update it as 2. Another node that I can go from 0 is 2. The distance to go from 0 to 2 is also 2. So it is also 2. So we will update distance array and we will write 2 here. Okay. Now we will be inserting all these elements. Distance 2, node is 1, distance is 2, and node is 2. Okay. We will pop this out of the set. Now we will get this one. The node is 1 and the distance already present is 2. Now where 1 can go to 0 up to 2. Now 1 can go up to 0. Now the distance from going 0 to 1 is 2. So the distance from again going 0 to 1 is the distance to reach the node 1 plus the particular distance from source to destination. So it will be 2 plus 2 which is equal to 4. But the distance of 0 reaching 0 node is already 0. So we won't be including it anymore. So answer now 1 to 2. 1 to 2 the distance will be it is 1. So 1 plus 2 which is equal to 3 which is greater than the already present one. So we won't be going through that part also. So let's remove all these things. Okay. As I told you, we will be simultaneously popping out the values. Now the node is 2. Distance is also 2. Now from where we can reach from the node to either 0, either 1, either 3 or either 4. Now 2 to 0 we will be having a distance equal to 4 because 2 is here and also we have already distance of 2 to reach the node number 2. So it is 4, which is less than, which is greater than 0, cancel. Node 1 or 2 plus 1 equal to 3, it is also cancelled. Now, yes, now we will be reaching node number 3. The distance is 3 and the distance from to reach 0 to 2 is 2. So the distance will be equal to 2 plus 3, which is equal to 5. Yes, which is less than infinity. So we will be definitely updating the distance. It will be 5. Okay. And 4. 2 to 4. Yeah, it is distance of 1 and the distance to reach number node 2 is already 2. So the distance from reaching node 0 to 4 is equal to 2 plus 1, which is equal to 3. Okay. It is less than infinity. We'll be definitely updating this. Now, how many nodes are updated? This one and this one. So we will be pushing them into the set data structure. So it will be a distance of 5 node 3 and a distance of 3 to the node 4, and we will be popping out this value. Okay, let's erase all this stuff. Now we'll be considering this value. So node is 3 and the distance associated with that node is 5. Now from node number 3 we can reach node number 2, we can reach node number 5, and we can reach, okay, there are only 2 elements in the adjacency list of 3. Now distance between 3 and 2 is 3, and the distance previously associated with the node 5, 3 is 5. So the distance will be 5 plus 3, which is equal to 8. We won't be considering it because it is far more greater than the value that we are 2. Okay. Now reaching node number 5, the value is 2. So 2 plus 5 equal to 7, which is less than infinity. Update it, and we are going to push that particular value into the set data structure. Distance of 7 associated with the node 5. Okay. Now, as I told you, we will be popping the values, or we will be removing the values from the set data structure. Okay. Now, next one is node of 3 having the distance 3. 4 having the distance 3. Okay. From 4, I can reach up to 2. I can reach up to 5. Now, distance from reaching 4 to 2 is 3 plus 1 equal to 4, which is greater than the distance present at the index number 2. We won't be considering it. Okay. Now 4 to 5. 4 to 5 is 3. And the distance to reach node number 4 is 3. So the distance from 0 to 5 will be 3 plus 3, which is equal to 6. 3 plus 3, which is equal to 6. Okay. But 6 is less than the distance that we have obtained, 7. See, the way that we did was this one. 3 plus 2, 5, and then we go from here. So 2 plus 3, 5 plus 2, 7. So this was the way that is currently stored. But this way is smaller. This only 3 plus 1, 4 plus 2, 6. So it is lesser. So we will be considering that particular way. Okay. So update it and write 6 here. And as I told you, we will be inserting a value. Distance is 6 corresponding to the node number 5. Okay. Now, then I hope everything is clear to you. Now, another node that will be popping out is creative distance is 3. Now from node 4 I can reach 5, I can reach 2, but I won't be considering because for 2 it will be distance 4, not considering, and for distance 5, 3 plus 3 6, which we have already here. So we won't be considering this also. Just remove them. What? Another node is 5 and 7. Okay, 5 and 7. From 5, we can go to either 3 or 4. 7 plus 2, 9. Won't be considering it because it is already 5. Similarly, we will be popping this also. Similarly, popping this also. So we will run this for loop while the set is not empty. I hope it is clear to you. So the final array that we have obtained, which is 0, 2, 2, 5, 3, and 6. This is our final array that we have obtained: 0, 1, 2, 3, 4, 5. These are the distances. Rather than distance, these are the शॉर्टेस्ट डिस्टेंसेस, मतलब जितने भी पांच पॉसिबल थे उसमें से जो सबसे कम डिस्टेंस वाला होगा वो सभी डिस्टेंसेस हमें यहाँ पे एरे में फाइनल मिल गए हैं from the source node, which is 0. And in question they can specify any of the source node, so the no difference will be there in the solution because we are writing distance of s equal to 0. So I hope this one is clear to you. Now time complexity. What will be the time complexity and what will be the space complexity? See, I think let us code first, then we will understand the complexities later. This was the adjacency list, and have a look at this for a while. If any queries, you can just rewind the video and go through that particular part. Okay. Now let's straight head to the writing of the code. We will be writing this code on the Geeks for Geeks website. I will be attaching the link for this thing in the comment section, so you guys can check it out. Okay, so first of all, as we have to return the vector, let's name it as distance, and I think every path is reachable. Okay, yeah. So what will be the size? It will be equal to number of vertices, and initial distance, as I told you, we will be writing as infinite, so it will be 1e9. Okay, now we will have a data structure of set in which we will be storing a pair of integer named st. As I told you, distance of source node we will assign initially to 0. So distance of s equal to 0, and we will be pushing st dot insert what? Distance initial and the node, which is source node. Okay. Now, for how much time we will be running the loop? While st dot empty, not empty, while set data structure is not empty. So auto it equal to uh, st dot begin and start at end, because st dot begin means the shortest distance we will be having, and if the distances are equal, it will be comparing the right hand side, which are the nodes. So s dot begin will have the value or the pair which is having the shortest distance. Okay, now int distance, let's say dist distance, let's weight equal to it of 0. Okay, and node equal to it of 1. Okay, now be iterating to the adjacency list or the pairs present or related to that particular node. Okay. Here also ADJ node equal to IT of 0. Okay. IT of 0 and int node GHT node weight equal to IT of. Okay. Now when we will be updating that particular node value or the when if the weight of that particular node plus distance of this node or this of this addition node is wait yes node GHT is less than this of ADJ node. At that time we will be updating the distance ADJ node equal to WGHT plus node WGHT. Okay, let's make sure there are no spelling mistakes. Okay, I think there are no spelling mistakes. My standard empty. Okay, and I hope the code is done here. Let's run it. I hope there won't be any kind of errors. Int WGHT. Oh, it won't be IT of 0, it will be IT of first because it is a pair. I hope now it will run without having any kind of errors. Okay, yes. It is giving time limit because we are not removing st.erase because we have to remove that particular node. Okay, sorry. It will give error because we have to also insert that particular node into the stack uh, with the distance this of a DJ node and a DJ simple. Okay. I hope now it will run without any kind of error. Let's submit it. Okay, guys. So this was the code here. Now this one was with the set approach. Okay. Please have a look at it. This code I written is of the priority queue approach. Here we are using a priority queue, which is also known as minimum heap, which returns the minimum value of that particular pair or integer, whatever we are storing it, which is the minimum. It is also a similar one, nothing much difference. Please have a look at it also. Now, why we are not using any queue of means why we are not using the queue approach? We are not using queue approach because in queue many times no, this queue. So the things that are stored in a queue are suppose 10, 5, 11, 4, 6, 3, and 2, 1. So if it is normal queue, then it will be processing this part first, after popping this part, after popping this part, after popping this part. But if it is a priority queue or set data structure, it will first process this part, which is the minimum, then this one, then this one, then this one. So that if conditions that we were writing inside will be minimized, because as we are processing the shortest distance one first, so all the associated nodes and their distances in the queue or set will be updated at that time only. Here in 10,5 they will be updated, but there is no chance that each and every one will be updated. So by using queue, some computations we are increasing unnecessarily. So that's why either use priority queue or set data structure as per your convenience. Now let us talk about time complexity. Time complexity is O of V square log V. Now let me tell you honestly, the derivation for this particular thing is quite complex. If you guys want to understand, please write it in the comments below. We will be making a separate video for just the complexity of Dijkstra's algorithm, and space complexities of V, because to store distance at each and every node we are using an array or vector of size V. So I hope guys this is enough for today's video. Dijkstra's algorithm, we have covered each and every part, each and every node in detail, and if yet any doubt, comments are free for you guys. Comments are open to you. Please write your reviews, please write your questions in the below, and we will be definitely making or a video or answering them in a separate video if needed. So, and if you find this video informative, please like the video and make sure you follow the channel for more. Till then, we'll meet in the next video, and yeah, please don't forget to write in the comments whether you want a separate video on the time complexity of Dijkstra's algorithm or not. We'll be definitely making a video if the comments will be there regarding this thing. So till then, goodbye guys. We'll be meeting in the next video very soon. So please give this problem a try definitely. And yes, if you guys are really interested in writing the code related to this, you can definitely check out the problem named shortest path. I will be also attaching the link shortest path with unit weights. Here the weight for each and every edge to each and every node will be 1. So here either you use priority queue or you use normal queue. It will be same for both the cases. So please definitely give this problem a try. I will be attaching the link in the comment section. So till then, keep learning, keep exploring. We will meet in the next video. Thank you.